Suppose that a 6 by 8 matrix has 5 pivot columns. And we're asked here, is the column space of matrix A equal to R5? And is the null space of A equal to R3? So what I want to do to get started here is to recall a theorem that we saw way back when we first learned about the null space of A and the column space of A. So let's keep in mind that for an M by N matrix A, we know that matrix A, of course, has M rows and N columns. And this theorem told us two things here. The first one is that the columns of matrix A, so the columns of A each have M entries, which tells us that the column space of matrix A is a subspace of Rm. Now we also saw in this theorem that a vector x that satisfies the matrix equation, matrix A times vector x, has n entries. And so therefore, the null space of matrix A is a subspace of Rn. So we'll want to keep this theorem in mind as we logically work our way through these two parts. So part A is the column space of matrix A equal to R5? Question mark. Well, we know for this given matrix here that we have a 6 by 8 matrix with 5 pivot columns. So we know that the columns of this matrix A each have 6 entries, meaning that the column space of matrix A is a subspace of Rm, or R to the 6, excuse me. So the short answer is no. No, this is not. The column space is a subspace of R6. So, moving to the second part here, make sure we can still see our theorem. Part B is the null space of matrix A equal to R3? Question mark? I don't know, let's find out. So we know that a vector x that satisfies the matrix equation, matrix A times vector x, has 8 entries. So this lets us know that the null space of matrix A is a subspace of R8. So is the null space of A equal to R3? No! We just showed that the null space of A is a subspace of R8. Now just for fun, because math is fun and we love math, with part A here, we can make a little note to ourselves that since matrix A has 5 pivot columns, we know that the dimension of the column space of matrix A is equal to 5. But is the column space of A in R5? No, it is not. We could also make another little fun math-loving note here. Again, that since matrix A has 5 pivot columns, that the dimension of the null space of matrix A is equal to the total number of columns, 8, minus the total number of pivot columns, which leaves us with 3. But is the null space of A equal to R3? No, it is not.